Okay. So, okay. So, yeah. Okay. So this sample problem, so caught by surprise near a supernova 是超新星哦，超新星就是超新星爆发的那个超新星，就是太粗了，超超新星，超新星。So you race away from the explosion in your spaceship, hoping to outrun the high-speed material eject towards you. 就是你的星球要爆炸嘛，就是那个超新星要爆炸了，所以你的飞船呢想要逃离它，然后 hoping to outrun the high-speed material eject towards you. Your Laurent factor gamma relative to the inertial reference frame 就是惯性坐标系 of the local star is 22.4. This is the gamma. So to reach a safe distance, you figure you need to cover 9 times 10 to 16 meter as measured in the reference frame of the local star. How long will the flight take as measured in that frame? Okay, so actually we have we have 22.4, which is the gamma. Which is the gamma, should be equals to this one. So it is just the definition, so nothing special. So actually, you can just move this to the left side, move this to the right side, and then square both sides. And finally, you can find that V should be equals to 0.999 C. 0.999 C. So this is the speed you should take. Actually, you are taking. So because you have this Laurent factor, so correspond to this velocity 0.999 c. And in that case, so the time should be 9 should be 9.00 times 10 to 16 over 0.999 times C is 2.998 times 10 to the 8th power. So this is the length. This is the contract length. This is the delayed time. So actually, this is 3 times 10 to the 8th second, which is 9.52 years. So actually, this is in your reference frame. And in that reference frame, it should be delta T0. Delta T0 should be delta T over gamma. Right? So this is the proper time. So this should be 9.52 over 22.4. So which is 0.425 year. Okay, so this is the first part. So the next part is like, how long does that trip take according to you? So, sorry. So this should be part A. And let me see, how can I select? Oh no. So this part should be part B. So actually, this is the time considered by that reference by that local star, because this is the delayed time. So it takes a longer time, just like the twin paradox. And for this one, we should consider the proper time, because actually you have a single clock on your starship. So this is the proper time. So this is delta T over gamma, which is 9.52 over 22.4, which is 0.425 year. Should be like this. So any question regard to this sample problem? Okay, so next. So this is the Laurent transform. Okay, so the Laurent transform, the Laurent transformation equation relate the space-time coordinate of a single event as seen by the observer in two inertial reference frames, so S1 and S2, S and S prime, where S prime is moving relative to S with a velocity v. So in the positive x and x prime direction. The four coordinates are related by this expression. So this is different from the classical mechanics. In the classical mechanics, we don't have this factor. We don't have this factor gamma. So here you consider this is the stationary inertial reference frame. So we denote it by x, y, and then this is stationary. And suppose, because stationary shouldn't exist, but these two reference frames are have a relative movement. So actually this another reference frame x prime y prime is moving in the x direction with a velocity v, So in the classical mechanics, you will consider if you have a reference frame here, x, y, and then we have another coordinate system, x prime, y prime, moving in the x direction with a velocity v. So you may consider, suppose as time t equal to 0, x prime and y prime is here. So maybe x prime is equal to y prime. Okay, so for t equals 1 second, oops. So when t, maybe using this. So when t equals to 1 second, x prime move to here, y prime move to here. So at t equals to 1 second, no, not y prime, and this should be x. This should be x. This should be x. So this x prime So this x prime should be x plus, this x prime should be x plus v times 1. Should be x times 1, like this. So this is the classical mechanics or the Newtonian mechanics in t equals to 2 seconds. X prime move to here. So x prime, should be minus sign. Should be minus sign. Should be somehow like this. T equals to 2 seconds. X prime should be x minus u times 2, something like this. Because if you consider a point at here, so y and y prime doesn't change, so it doesn't really matter. So if you consider x t equals to 0, so this point is here. So it is larger, and when you consider at t equals to 1 second, so your x prime axis reduce something, and then for t equals to 2 seconds is further reduced, so it should be minus sign rather than the positive sign. So in this case, for Newtonian motion, it should be somehow, you just need to remove this gamma factor, the Laurent factor. But here we need to consider this gamma factor to make everything all right. And since the relative motion is not in y and z axis, so these two is normal. And actually, we also need to have some transformation for the time domain, because as you can see, we have not only length contraction but also time dilation. So we need to have some transformation between the time. But in classical mechanics, the t prime should be equals to t. So this is a classical mechanic. But but when we consider the relativistic effect, we need to use this equation. so it's nothing special. And so this is the one if you have the x, y, z, and t coordinate, and if you want to change it to x prime, y prime, z prime, t prime, you use this 37.21. If you want to make the reverse one, you use something here. Okay, actually you just need to solve it. You just need to move x to the left hand side and the other stuff on the right hand side. Or for this case, you need to move t to the left hand side and all the other stuff on the right hand side. So you feel like you have a t. Maybe for the first one, you have something like x prime over gamma plus vt equals x, something like this. And for the third on the last one, maybe something similar. It's just a simple algebraic calculation. So now we consider the displacement rather than the distance and the delta t rather than the single point, because what we talk about is the relativity. So relative motion, relative time. So suppose you have two 2x, 2t, and then you subtract them, so it will come up with a similar expression. You will come up with some similar expression. So it needs to satisfy this equation. This equation looks quite complicated, but actually this is a constant term. This is the conservation term to take. So ct is c square t square is the c is a constant, so also constant for this one. So t and t pi can change. So this is a time dilation, and the later term is the length contraction, but they need to somehow consistent with each other. So in this case, as long as we know that if the relative motion is in x direction, so we have a y prime equals to y and z prime equals to z. So this is, so you can just forget these two terms. So we don't need to consider about that. So next, for the left side, we have, or for the right side, we have c square t prime square minus x prime square. So you can just substitute. We can just substitute. We can just substitute this one. This one t prime equals gamma t minus vx over c square. So we have a c square gamma square t minus vx over c square, and then quantity square, and then minus x prime should be gamma square x minus vt square. So you just substitute the first and the fourth equation in the previous page, so 37.21. So you just substitute there, and then you try to explain it. So we have actually we can factor out gamma square, so that we have a gamma square, and then this one we have a c squared t squared minus 2 times vxt over c squared times c squared. So this is 2 times vxt, and then plus v square x square minus c to the 4th power, and then multiply by c squared. So it is c squared in the denominator. So minus gamma square x square, and then plus 2 gamma square x vt minus gamma square v square t square. No. We have already factored gamma square out. We have already, so we don't have gamma square here. Should be something like this. So in this case, we can see that this term and this term is the same, but with opposite sign, so we can just cancel them. And so gamma square. So first we have this term and this term. So we have a common factor of t square. So we have t square c square minus v square. And then for this one, we can factor out x square x square, so that x square, so we have v square over c square minus 1. So we have v square minus c square over c square, something like this. So next we can just factor c square minus v square. So we have something like this. So we have t square minus x square over c square. So actually gamma is 1 over 1 minus v square over c square multiplied by c square minus v square. And then we can factor 1 over c square out. So here have c square t square minus x square. So this one is actually this one. So we can find that c square multiplied by this one will be c square minus v square, and then we can cancel with this one. So finally it becomes c square t square minus x square. So as long as we have this Laurent transformation, it could satisfy this second postulate of the relativity. Which means the speed of light should be a constant in any inertial reference frame. So actually we have verified that the Laurent transformation is good to use in the special relativity. Okay. Any questions? Okay, so maybe I can, yeah, no, not now. So we have another sample problem. So an Earth starship has been sent to check an Earth outpost， 就是那些哨站 on a planet P1407 whose moon houses are battle group of the often hostile Reptilian 就是应该是蜥蜴人的意思吧，就是敌对的蜥蜴人啊。那我不知道那个英文是不是，因为 reptile 还是不知道，反正就是敌对的外星人吧。那at the ships follow a strict light course first past the planet and then past the moon. It detect a high energy microwave burst， 就是有一个爆炸，有一个微波的一个脉冲吧。At the reptilian moon base， 在那个月亮的基地 ，and then 1.1 seconds later, an explosion at the Earth outpost, which is 4 times 10 to 8 meter from the Reptilian base, as measured from the starship reference frame. The Reptilian has obviously attacked， 就是那个蜥蜴人啊，就是进攻了那个地球的那个哨站，就是星球大战嘛。So the starship began to prepare for the confrontation with them. Confront 就是投降嘛，所以就准备投降，因为被攻击嘛，所以the starship the speed of the ship relative to the planet and its moon is 0.98 c. What are the distance and time interval between the burst and the explosion as the measure in the planet moon frame? Okay, according to the occupants of the station， 就是那个占据者在那个station 上面的 occupants。所以现在啊 ，so now we have a two reference frame. One is actually your ship, and the other reference frame is the planet. So actually, you are moving from the planet and the moon, but actually you can also regard that you are the stationary and the moon and the planet are moving away from you. So actually they are the same. So in this sample problem, we consider the reference frame for our ship is x and is x. So actually the moon planet system is moving away from us by a speed of v, which is roughly 0. which is 0.98 C. 0.98 C. So we need to distinguish what is this, whether it is t or t prime, whether this is x or x prime, something like that, to make everything all right. So here we denote the explosion as E, and then we denote the bursts as B, because there are actually two events. One event is the explosion, and the other event is the burst, is the microwave burst. It's the microwave burst. Actually, you feel that the microwave burst occurs first, and then 1.1 seconds later, and you feel like the planet explodes. So actually, there are two events. So now we suppose the starship is stationary, and then we have a delta X, which is XE and minus XB, XE minus XB, which is the distance between them at your reference frame, and then delta T should be TE minus TB, which is 1.1 second. 1.1 second. Also on your reference frame, because this is what you can feel 1.1 seconds later, what you can feel. So this is delta T. So next, we'll consider delta X prime, which is gamma times X minus Vt. And actually we can just calculate gamma to be 1 over square root of 1 minus V over C squared. So which is 1 over 1 minus 0.98 square, because V is actually 0.980 C. So this Lorentz factor is 5.025. So in this case, gamma is 5.025, and then X is delta X should be delta X, delta T. So delta X should be this one. Because this 4 times 10 to 8 meter from the base is measured from the Starship reference frame. So this is 4.00 times 10 to the 8th minus V is 0.98 C, 0.98 times 2.998 times 10 to the 8th power, and then multiply by 1.1. So this becomes 3.86 times 10 to the 8th meter. And also we can calculate delta T prime, which is gamma t minus v delta x over c squared. So we just substitute using this one. So we can substitute 5.025, and then this is delta t. This is delta t. So delta t is 1.1 minus v is 0.980c, and then multiply by delta x is 4 times 0 times 10 to the 8th power. So one is c, one is 2.998 times 10 to the 8th. So one of the c can be cancelled, so I don't write both of them. So finally, we can find that delta t prime is minus 1.04 second. Minus 1. Which means that this one should be delta t prime should be te prime minus tb prime. Which means that this one occurs first at this reference frame. The only thing you feel that this one occurs first is at your reference frame is that you are closer to the moon, so you feel this one occurs first. But actually, when you consider that reference frame, this one should occur earlier, and here, and you feel the burst first. Because you are closer to it. So you feel the burst first. 就是用中文说，就是在你的坐标系上面你先感受到这个 burst， 1.1秒之后才感受到这个 planet， 但是在x prime s prime 这个坐标系上面，其实这个是小于0嘛。小于0的意思是这个比较小，这个是先发生的，这个是occurs first， 这个是先发生的。那变成说，在这个坐标系上面，这个t prime 比较小，在你的坐标系上面t1是比较大的，这是因为你比较靠近这个 moon， 所以这个 explosion 传过来的是需要时间的，而且它的距离蛮远的，它的距离是4乘以10的8次方，所以变成说你会感觉到就是 moon burst 比较先，但其实在那个 S prime 这个坐标系上面是那个explosion 先发生的，所以那个蜥蜴人是无辜的。结论是蜥蜴人是无辜的，就是对，这个就是结论，算完一大堆，就是蜥蜴人是无辜的So what is the meaning of the minus sign in the delta t prime？ 那我就说明了，就是 so in the moon planet system reference frame, delta t prime equals t prime e minus t prime b is smaller than 0, which means that so the explosion occurs first， 就是那个爆炸是先发生的，它是先爆，它才那个电磁脉冲，因为它就是那个电磁脉冲就是一种高能量的武器嘛，它是说 high energy microwave burst， 就是电磁炮啊那种感觉，所以你在算之前，你以为就是就是那个电磁脉冲炮把那个星球打爆，但是其实不是啊，是那个星球先爆炸，它才发射那个电磁脉冲。所以 any questions？ 对于星球大战有没有问题？然后第 C 的问题是did the burst cause the explosion？ 那因为就是 explosion 是先发生的嘛，所以是所以不是嘛，所以是 no 啊，所以是 no。就是第一个相对论的那个假设，他说不同的惯性坐标系底下，它的物理定律是一样的，所以那个听起来好像有点抽象，但是这个就是这里所谓的因果律就是它的你严格按照那个算出来之后，你就会知道它的因果律不会违反，所以就是它先发生的事情就不会被后来发生的事情所影响，所以这个是关于那个第一个，然后 and then also, it mentioned something about checking the speed. Also, the required speed of the information in the shifting frame. This speed is v info, which is xt over delta t. So it is this one, which is larger than c, but that speed is impossible because it exists c. In the planet's moon frame, the speed comes out to be 3.7 times 10 to 7 meters per second, also impossible. Therefore, neither event could possibly have caused other event. That is, they are unrelated events. Thus, the starship stand down, not confront the reptilian. 所以那个意思是说，如果这个电磁脉冲要引发这个星球的爆炸的话，那这个星球爆炸那这个电磁脉冲啊，就要用这个速度来传输，才会发生这个事情。但是这个超过光速是不可能发生至少在现在为止，它是不可能发生的。所以这个就是会违反那个物理定律违反物理定律。So let's have a 15 minutes break.